Now for the final project of the class. I like to refer to it as the Choose Your Own Adventure project. We're going to go back to the second page of the table of contents where we saw the automation through programming before. We're going to start at task 1, spinning sign. Now in this project, you can choose any of the tasks available that we have not already done or have not been explicitly forbidden by your instructor. Some of these are significantly more difficult than others, and some of them have one type of skill. For example, one might be strong in mechanical engineering where you need to build something versus weak in programming where you don't have to do that much. Now, I'm going to describe each of these not as they're written, but how I prefer to have them executed in the classroom. The spinning sign needs to have either 2 different spinning signs that are run at the same time and are kept in sync with each other, or one spinning sign that has a direction of movement change from where the motor is to where the sign spins. Now, this sign needs to also have an on-off switch as well as to be regulated by the light. So for example, if this sign was in a mall and the lights were turned off, the sign would cease to spin. Or if it were daytime and somebody needed to change the message on the sign, they could press the on-off button and that would stop the sign from spinning. You can read here that you're going to need to consider different sensors and motor setups. Please make this as creative as possible. This is one of the easier projects. However, if you're not creative, this project is very boring and will not be very interesting to your classmates or you. Next up, we have to skip the robot drag race because that one we did in a previous unit. Next up is the Terry traffic timer. The Terry traffic timer is one that is very easy to build, although it is very difficult to program. What the idea is, you're creating a 6 LED stoplight, 2 red, 2 yellow, and 2 green. 1 red controls north-south traffic, and 1 red controls east-west traffic. Same with the yellow and green. There's 1 set of red, yellow, and green lights to control north-south traffic, and 1 set of red, yellow, green lights to control east-west traffic. Now you're going to first create the road that all of this is on. Now you can use the testbed platform to do this. You will create the traffic light, which can either be 2 separate lights, or you can have 1 light with the LEDs facing in different directions. You are going to need to use the extension cords in order to do this. You cannot use the LEDs plugged directly into the brain. When using the LED and the extension cord, be very careful. If you do not put them together properly, you could end up creating a fire, or the LEDs won't work at all. Please do not use the LED extension cord and the LED together to hold them within a piece of metal, because that will bridge the two and your LEDs won't work very well, or they will catch fire. You need to be careful. Not only do you need to create a pattern that will simulate a regular traffic light where one side is red while the other side is green, then goes to yellow, then goes to red, then waits while both are red before the next one goes to green. That is a standard traffic light. This one also needs to have a button that will override each direction, so you'll need a minimum of 2 buttons to override the traffic light. When one button is pressed, that direction, north-south or east-west, will turn to red, and the opposite direction will turn to green. Once the button has been released for the first choice you made, regular traffic will resume. For the second button, it will create a red/green direction change and hold it in the other direction. So if your first light turned north-south green and east-west red, your second button will turn east-west green and north-south red. And then when it's released, normal traffic pattern will resume. Next up is the toll booth. The toll booth you are going to create will allow a car to pull up. It will have a basket that something can be placed into and be sensed, and then allow the toll gate to raise up, and then the toll gate will stay up until it is sensed that a car has passed all the way through. This way the toll gate does not come down, damaging the car or driver. This one is middle of the road because it requires about an even amount of mechanical engineering and programming. Next up is Grandma's chair. Grandma's chair is one of my favorites. With Grandma's chair, you're going to create an L-shaped platform by combining two base plates. One is going to be attached, or one is going to sit flat on the tabletop, and then one will be attached at 90 degrees to it. You will create a system using mechanical gears of any choice of yours to get a chair to move up and down as if it was a handicap-enabled chair to lift Grandma to and from the first and second floor. There needs to be sensors on each floor to tell the chair when to stop, and there needs to be a call button on the first and second floor in case somebody else has used the chair and Grandma needs it where she is at. In addition to this, you will also need, if you'd like to challenge yourself, to create an emergency override that while the chair is in motion, Grandma will go all the way back down to the first floor. The emergency override is not necessary for completing this project, although it is a really good design to have. Now, the other set of buttons you will need is a set of buttons to make the chair go up or down once Grandma has gotten onto the chair. So this becomes a very difficult design to build because there's a lot of buttons and sensors involved. However, the programming itself can be challenging as well. I strongly recommend that you understand while loops with conditionals if you're going to do this one. Next up is the TechRox bridge. I have gotten away from the design of a turntable bridge and I allow any bridge to be built. However, my caveat is that there needs to be a sensor to detect the approach of a boat from either direction. And then, once a boat has been detected, then to have the bridge move out of the way, whether it's a turntable bridge or whether it's another style of bridge based on a design that you've researched. When the bridge has moved out of the way, there needs to be a light to inform drivers that the bridge is not available. So a red light should go off telling drivers to stop. Then the sensors underneath the bridge will know once the boat has passed and then lower the bridge back into place. Mechanically, this is not a very difficult project to build, nor is this a very difficult project to program. However, it will take some thinking and some trial and error to find a solution that works best for you. Next up is the road trip. The road trip is one that I do not usually allow. However, this one requires a lot of things to be built into a new car, and that will include a lot of individual pieces of programming. You need to turn the headlights on. You need to put the vehicle into reverse to back up to the right out of the driveway for 2 seconds. Whenever your car is in reverse, make sure that your backup lights are on. You will stop the vehicle for at least 2 seconds before going forward and turn off the backup lights. The vehicle in forward to drive down the road toward Alex's house for 5 seconds. Upon arrival at Alex's house, turn right onto Broadway to park in the street. Turn the vehicle and the headlights off. After 4 seconds, Alex gets in the car and it's time to go. You will turn the headlights on and put the vehicle in drive. Drive down the road until reaching the theater, a 3-second drive. Turn left onto the theater and park the car by turning the vehicle and headlights off. Watch the world's shortest movie. 5 seconds later, get back in the car. Turn the headlights on and put the vehicle in reverse. To back to the right out of the parking spot, 2 seconds. Don't forget the backup lights should come on whenever your car is in reverse. Stop the vehicle 2 seconds before going forward. Turn off the backup lights. Put the vehicle in drive and drive back to your house. Alex is spending the night. A 4-second drive on Broadway. Turn left and then a 5-second drive on Lake Road. Turn left into the driveway and shut off the vehicle and lights. You are home again. This is a very complex design. Although it does not require much to build, a basic car structure, some LEDs. However, this is a very complex design to do in programming. It requires a strong ability to follow instructions and to pay very careful attention. There is a bonus. Experiment with a wait time to get your vehicle to return within 10 inches of the same location it started. I've done this by using the same box, although I use a much larger box, that I use for the robot drag race to see if the car can return to that. Next up is the stay on course. This is the one that many students want to do to create a tank. However, they don't actually have the effort into it once it comes to building the tank. So in order to do this, you are going to create a tank that will follow a 1/2 inch black line so to stay off the hostile battlefield. This requires a great deal of programming beyond building the tank. This requires you to follow carefully and create a line follower method that will ensure that the tank does not deviate from where it's going. You can create the line follower method, however, the vehicle must stop and drop off supplies, then continue back to the base and stop. The few students who have tried this, I have requested that they need to make at least 4 turns while they do this. This can become very difficult if you are not good at programming, and the line follower is not something that reads very well. So a tank may look cool to build, however, it is very difficult to program and actually make happen. The pick and place. The pick and place is one of my favorite. It is where you create a claw that will pick up an object that is placed on some sort of sensor to detect it. Once the object has been grabbed, the claw will then lift the object, turn the object, and place it somewhere else, carefully without knocking the object over. I strongly recommend you using something as an object that has a very stable base so that it does not fall over easily. I will not tell you exactly how you are going to do these things, but you will detect an object is in place, you will then pick it up, you will lift it, you will turn it, and you will place it back down. Once the object has been placed, the robot will return to starting position. And then finally, the Freight Elevator Challenge. The Freight Elevator Challenge is by far the most difficult of all the challenges. You have a 3-story elevator. You need to make it so that the elevator will be able to be programmed to go to any floor by the user that's in it. It can be called to any floor by the buttons that are on it, and when in doubt, return to the first floor. This can become a very difficult challenge. It is both mechanically very complex and programming-wise incredibly difficult to do. Even experienced programmers who have used VEX Robotics before will take a long time to create this challenge. If you feel that you're ready for it, be aware that you may not finish in time. It becomes a very difficult project to make. There's also going to be other things like a wait button and call buttons, so make sure that you read carefully what is involved in the Freight Elevator Challenge. And that are the challenges for your Choose Your Own Adventure. If you have any questions, please check your instructor, and as always, remember that your instructor's objectives for you outweigh anything that you heard in this video.